Hi everyone, welcome to this module on the OCI private load balancer. In the previous module, we have talked about the public load balancer and seen it in action and some of its key components in action. Let me quickly jump to the console and show you one thing which we couldn't complete in the previous module, the demo where we demoed the public load balancer, and that's around health check. So as we said, the health check has a 3-minute granularity, and when I was doing the demo, I ended at the public load balancer IP. I showed the IP, but the health check was unknown at that time. So if you see here, you can see the overall health is okay, and the backend sets health is okay, and then I can also see the health check for each of my backends. So if I click on my backend set here, I can see that the health is okay, and if I click here, I can see the health is okay, shows here. And if I click on the backends, I can see the health okay for each of these backends, right? And if I can, if I hover over there, I can see that some of these details where the health check is running on 2 instances. So I can see some more details here, right? Now, a couple of things I could do here, which again I didn't show in the previous demo, is if I pick up a particular backend, I have several actions I can take. Of course, I can change the ports, etc. The weight which I give, it's a weighted round robin if I want to change that. But I can also do things like drain the state. And if I click here, it basically draining means that I disable new connections. The load balancer stops forwarding new TCP connections and new non-sticky HTTP requests to the backend server. So this is good for scenarios where I want to do maintenance. I want to take out a backend set out of the rotation of the backends I have, right? So I could just click through here and save the changes, right? I could do that. I could also come in here and I could edit my offline state, and basically this disables ingress traffic altogether. So the load balancer forwards no ingress traffic, no incoming traffic to the backend server. So I could do that as well. And the third one is edit my backup state. So in this case, I can set my server as a backup unit, and the load balancer forwards ingress traffic to the backend server only when all other backend servers not marked as backup fail the health check policy. So this is good for disaster recovery scenarios. If I have scenarios around that, I could actually use this option, right? So a bunch of options I could use here. Remember again, health check is at the backend, aggregated at for each of the backend. You have a health check, and then you have a health check aggregated for the backend set, and then you have a health check for the overall load balancer. And if you don't see any of these as okay, that means something is going wrong in your load balancer, right? And you need to investigate further. There are also a bunch of metrics here where you can see your inbound active connections, etc., etc. If I click on my backend set, I can see some metrics for my backends as well here, right? So you can see unhealthy backends, how many backends server I have. You can see the both backend servers are here. There is nothing which is unhealthy, etc., right? So I can get some more details if I want to investigate further. So anyways, let me go back to my slides and talk more about the private load balancer. So private load balancer is assigned a private IP address from the subnet hosting the load balancer. Makes sense, because this is we are talking about a private load balancer. So of course it will have a private IP and not a public IP. The load balancer can be regional or AD specific depending on the scope of the host subnet. So you could choose either AD specific or regional, like you could do with a public load balancer. And primary and standby, though actually we should not use primary and standby, we should use active and failover as sort of the terms. So active and failover load balancer each require a private IP address from that subnet. So let's see how this works in action as we saw with the public load balancer. So I'm using regional subnets here. So I have a region, of course all regions, multi-AD regions have 3 ADs. I'm only showing 2 just to keep the picture a little cleaner. And so right now I can create a private load balancer in my AD1. Of course it's a regional subnet. So failover gets created in AD2. And like we said, this is a private load balancer, so it gets a private IP address. And then like with a public load balancer, you could send the traffic to the backends, whichever ADs they exist. Now, in case of AD specific subnets, there is a change here where my active and my failover are both in the same AD, right? So yes, we still have two copies, but they're both running in the same AD. And in this case, my subnet is AD specific subnet here. It's not a regional subnet anymore. It's AD specific. So hopefully now you can see why we advise you to create sort of this regional subnet, so we can create a failover copy right here, right in another AD. If you have regional subnet, if you have AD specific subnet, we with at least the private load balancer, the failover copy gets created right here in the same AD. So with that, hopefully this give you a quick overview of the private load balancer. I don't have a demo to show private load balancer in action. Why would you use a private load balancer? Well, if you have an application where you are talking, you have a web layer, you have let's say a middle tier, and you have a backend tier, you could have a load balancer sitting between your middle tier and backend tier, right? You could have a private load balancer, and you could have a public load balancer sitting at your web tier, taking the traffic from incoming traffic, sending it to your web servers, and the web server could talk to the middle tier using a private load balancer, just if you want HA and distribute the traffic. And you could have a private load balancer between your middle tier and your backend set and your backend tier. So hopefully this gave you a quick overview of private load balancer. Thank you for watching this lecture series on OCI load balancing service. Thank you.